So in this video, we're looking at the applications of trigonometric rules in conjunction with our right angled trigonometry from Nat 4. Because sometimes a SOHCAHTOA question is hidden behind a sine rule or a cosine rule question, and so you need to apply the sine rule or cosine rule first, and then you can use your right angled trigonometry in order to determine a missing angle or side. So in this example, we want to estimate the height of a building, and two pupils find the angle of elevation from a point A at ground level down the street to the top of the building at 35 degrees, and from a point B that is 150 metres closer to the building, the angle of elevation at ground level to the top is 51 degrees. And we're assuming that the street is level, and we want to estimate the height of the building. So we've got a diagram here. We wouldn't necessarily be given that. Sometimes we would have to create the diagram ourselves. But we can see that at point A, the angle of elevation is 35 degrees. So we want to annotate our diagram and put the 35 degrees in from point A to the top of the building. We're also told that point B is 150 metres closer to the building. So that means our distance AB is going to be 150 metres. And the final piece of information that we're given in the question is that the angle of elevation to the top is 51 degrees at point B. And so we're going to write that on at angle B to the top of our building is 51 degrees. And the other piece of information that we can write onto our diagram is that if we are assuming that the street is level, the angle between our building and the street is going to be 90 degrees. So in order to work out the height, if we've got our angle of 51 degrees, we want to work out the length of the line from point B to the top of the building. And we're going to mark that on as length x. So now we want to sketch that triangle so that we can determine the length of x using the information that we've been given. So we've got angle AB, and if we call the point at the top of the building C, the distance of AB is 150 metres. Angle A is 35 degrees, and we want to determine what the length of BC is, which we've called x. Now, in order to use the sine rule, we need to work out what angle C is, and we're going to have to go back to our original diagram in order to help us find that information. Now, because we know that angle A is 35 degrees, and the angle between the base of the triangle and the building is 90, we can determine the angle marked in green by doing 90 take away 35 equals 55 degrees. And we can do the same for our red triangle by doing 90 take away 51, and that's going to give us an angle of 39 degrees. And so angle C is going to be the difference between 55 and 39, and that gives us a value of 16 degrees for angle C. So we've got our pairs of angles and sides opposite each other, as we can mark in our diagram, and so we know that we can now use our sine rule. And it's a sine rule to work out a missing side, so it's A over the sine of angle A equals B over the sine of angle B. So, substituting in, we've got x over sine of 35 degrees equals 150 over the sine of 16 degrees. And so x is going to equal 150 multiplied by sine 35 all over sine 16. And putting that into our calculator, we end up with a value of x equaling 208.09 and so on. And rounding it to the nearest metre, we get 208 metres. So now we want to sketch our right angled triangle and use our right angled trigonometry to work out the height. So we know that the angle at B was 51 degrees, and we now know that the distance x is 208 metres. So we need to write SOHCAHTOA to determine which one of our ratios we want to use. We've got the angle, so we could use any of the ratios. We've got the longest side, which is our hypotenuse, and we've got the opposite side, so that means that we want to use our sine ratio. So we're going to write sine x equals opposite over hypotenuse. We're going to substitute in our values. So we've got sine of 51 degrees equals h over 208. We're going to do some rearranging to get h equals 208 multiplied by the sine of 51. And putting that in our calculator, we get 161.6 and so on. And to the nearest metre, we end up with a height of our building of 162 metres.